What's up? I'm Jake.
And this is Steven Delpino.
And this is the physics of stunts.
What are we gonna call it?
And the bass keeps burn it till it's burned out, turn it till it's turned out. Act up from the west east side. Everybody, everybody, let's get into it. Get stoned, get it started, get it started, get it started. Let's get it started. Let's get it started in here. Let's get it started. Let's get it started in here. Let's get it started.
Alright, stunt 1, momentum and impulse.
Well, you can see that both guys are at rest, hence their velocity equals 0. If we were to calculate their momentum, it would also be 0 because their mass times their velocity, which is 0 meters per second, is also 0. You can see now that both bodies are in motion and their velocity has increased. And since velocity and momentum are directly proportional, momentum also increases. Now there's a wall ahead. When they collide into the wall, they will experience a great amount of change in momentum, which is also called impulse. But the result is pretty funny.
This is part 2, the momentum and impulse.
Okay, so now we're making them run into a fence, which has a little bit more cushion since it's built to move back and forth a little bit. That increases the amount of time of impact, which decreases the amount of force or change in momentum, which is impulse. You're less likely to fall down and get hurt. Andrew does, but that's just him.
I didn't even fall.
This is stunt 2, and this is projectiles.
What am I doing?
You didn't jump off, Mike.
You jumped.
Okay, so Mikey's launching himself off the swing as if he was a projectile. His path was parabolic, his trajectory. It's supposed to be because of Earth's gravitation pulling you down once you're in the air. Andrew's path is also parabolic. He also has a nice jump.
I didn't even go that high.
This is stunt 3, centripetal force.
I'm not even spinning yet. I'm barely even spinning.
So right now they're spinning Andrew, and the centrifugal force effect is basically just that like force, this imaginary force that's like pulling, wanting to pull something out of a circular path. If you look at the top of the ropes of the swing, you can see that it's moving outwards in a circular path, but the centripetal force is keeping him inside, which is a force directed towards the center of the circle. And I guess now he's taking a break.
Dude, I got like the biggest nut bulge right now.
Okay, hold up. This is stunt 4, constant acceleration.
Well, right off the bat, besides acceleration, we could also say that up there, Kyle has a lot of potential energy, which is energy that has potential to transform. And as soon as he slides down, that energy turns into kinetic energy, which is the energy of motion. Now, as he slides down, he will have a constant acceleration while falling down until he hits the floor. So let's see what happens. I think it's pretty funny. He flips.
Stop!
Alright, stunt 5, elastic collisions.
So in an elastic collision, one object collides with another and transfers all its momentum to the other object. This abides the law of conservation of momentum. In a perfectly closed system, net momentum is always the same before and after a collision.
Stunt 6 in elastic collisions.
In inelastic collisions, objects sit together and still conserve momentum.
Damn, that's far enough. Shit.